Alright, so our app is working fine, but users of modern web apps expect the UI to respond instantly, and our app should be able to respond to the user inputs faster than it takes to make a whole round trip to the server. We call this optimistic UI updating. So if you see, for example, the contact list, and if you take a look at the method that remove a contact, when we click on that button, when you click here on the remove link, we are calling this Meteor call. And to support optimistic UI, we should import our Meteor methods not only on the server side, because we are importing already the contacts methods on the server side, but we should also import these methods on the client side right here. We're going to see other ways of importing methods, but let's keep that way for the moment. So just doing that, Meteor will support optimistic UI. And what I mean by that, if you look at this illustration, we can see a few important components in our Meteor application. So we have the client-side JavaScript, we have MiniMongo, that is our client data cache. We have DDP, a protocol created by Meteor using WebSockets. We have Node.js on the server side, and we have MongoDB also on the server side. So when we call a Meteor method from the client side, we are doing like this, and we are sending the data from the client to the server side. So this data is processed and validated on the server side. We insert it or remove it from MongoDB, depending on which action we're taking. And then this data will go back to the client side. It will go first to the MiniMongo, and then we will show this change in our HTML, in our React UI in our case. So this is the regular flow, but there is an issue on this, that is the network latency. And what I mean by that is when we send this data over the network, we have some time, we have some delay to get the answer from the server side and then to present to the client side. And actually using optimistic UI on Meteor, when you call a Meteor method on the client side using Meteor call, two things happen at the same time. We send this to MiniMongo, and we also send to the server to run in a secure environment. And then a simulation of this method runs directly on the client, trying to predict the outcome of the call. So we insert the data in MiniMongo and represent this data on the screen immediately. So we call this latency compensation. And then at the same time, this data is sent to the server, and then it will be processed there. It will be inserted in MongoDB, and then this data will come back, and we will calculate and check what is the real result. So if the data was inserted correctly, it will keep the state of the screen. But if something went wrong, that data will be removed. So if we're talking about inserting a contact in our Meteor wallet, we can actually use that Meteor DevTools evolved extension so we can see what is going on. So remember, we can see here the MiniMongo, and we can see that we have a few contacts here. Right now, we have 5. So if I add a new one like this, and I image URL, we are going to see that this contact will be inserted to MiniMongo. So we can actually see here on this tab on DDP that this contact was inserted. So this call was sent to MiniMongo. And then we can see this one, this message means that this contact was actually inserted in MongoDB. But first, it was inserted on MiniMongo, then sent to the backend, and we got this answer from the server. We can even check in the code if the code that we just run was a simulation or if it was a real call. So if you go to contacts methods, and we can check this on the remove method, we could check right here if this is a simulation. So I'm going to do this. If it's a simulation, I will remove the contact. We could even do like this, just to check on the console log that this contact was not removed. So we will print this on the console on the server side. So now if you try to remove some contact like this one, and we can check the console log right here. Let me clean it. I will try to remove this one. And well, yeah, nothing happens. But if we slow down our CPU a little bit from here, we'll be able to see this element blinking. So Meteor tries to remove this, but what is happening here is that the client side is removing from Minimongo, and it is trying to show that result on the screen. But at the same time, a Meteor call was sent to the server, and this call is the one that always wins. So it is really quick, but we can see this data blinking. And we can also check that we have this in our server side. And Meteor does that for us automatically. It would be very hard to build an app and correctly implement this client-side simulation, and it would take a lot of work to make the UI consistent and keep the data in sync with the client-side data cache and the MongoDB on the server side. So Meteor does all of that for us. And the only thing we need to do is to have the methods imported on the server side and also on the client side. But now let's remove this simulation from here and this as well. Let's check if our app is working fine. So I will remove this. Yep, it worked. And then I will stop the server, and we are going to send this code to Galaxy. So this is a good time to commit our code, and I can say that we just implemented Meteor methods with optimistic UI. And when we push this to GitHub, Meteor will trigger a new deploy and will update our Galaxy server.